Hello, my name is Mr. Wilke, and I'm here today in my classroom. That's exciting, right? They opened up the building today. They said, hey, come in, grab your stuff. I'm like, you know what? I'm gonna come in, I'm gonna use the smartboard. And anyway, class is still empty. As you can see, look around, desks, nobody there, nobody there. Look, Descendants shirt, Descendants poster. It's college gear day. Milo went to college. You can go to college. All right, let's set that back up and let's go over the test. As you can see, there's 8 multiple choice questions, 3 free response questions. So let's start with the multiple choice and then we'll go over the free response. You'll be ready for the test. Everybody gets an A, right? No cheating. I know you're gonna be taking it home, but no cheating. All right, so number one, I will basically ask you what family or what member of the chi-square family is it? What am I basically just asking about? That's right, degrees of freedom. Good. Degrees of freedom tells you what member of the chi-square family it is. Do we remember how to find degrees of freedom? For a goodness of fit test, it's just what? No? Good. N minus 1 is correct. All right. For a Harry Potter artificial intelligence. Good. Homogeny of populations, association, independence. All right. Homogeny of populations, association, independence. It's R minus 1 times C minus 1. Okay? Easy. Very easy. Remember, it's not the counts that's N minus 1, it's the categories. Okay. Number 2. Where do we reject? So what you got to do is you've got to find the p-value. If the p-value is less than alpha, you reject. If the p-value is greater than alpha, you fail to reject. So you're going to have to do some sort of chi-square test, find the p-value. Where do we reject? All right, number 3. Find the expected count. Now, you can do this one of 2 ways. You can do this the easy way, or you can do the whole test. If you need to do the whole test anyway, you might as well do the whole test, look at the expected matrix, and go from there. Or, if you don't have to do the whole test, it's just row total times column total over table total. All right? So if I give you the matrix, you can put it into your calculator, you can run the chi-square test, you can look at the new matrix, or just figure out row total, column total, table total. And that's it. Easy. Cool. All right, number 4. What is true or not true about a chi-square test? I could ask you about the hypotheses. I could ask you about the conditions. I could ask you, do we have a chi-square confidence interval? No, that wouldn't make any sense. Okay, I could ask you that. Who knows? Just things about the chi-square test. What's true, what's not. You should definitely know what your hypotheses are going to be. You should definitely know what your conditions are. You should definitely know how to find each component of the chi-square test. Now, that's a good question. Okay, so yes, there will be a formula. Chi-square equals so that will be available to you. Okay, good enough. Cool. All right, let's move on. Number 5. 5 through 7, I think, maybe 8. Number 8. All right, 5 through 8. I'm going to give you some scenario, some experiment, something you're going to answer questions on it. So you will have to come up with now on this one, where do we reject? You'll have to figure out, well, look at the chi-square chart. Yes, a chi-square chart will be available to you with the test, okay? So where do we reject? Well, look at the chi-square chart, you'll be able to find it. All right, number 6. P-value, we know how to do that, right? Find the chi-square statistic. You can do chi-square CDF, or you can just run the chi-square test on your calculator. It'll give you the p-value. Number 7. What just happened? Apparently my sleeve hit the, there we go. This didn't happen at the whiteboard at home, did it? All right. So, p-value, 7. Which cell contributes the most? So basically what you got to do is you got to look at your work and see, okay, which ones got the biggest observed minus expected squared over expected. So if it's a big difference, that'll help. Small expected will help too, okay? All right. Number 8. What is the conclusion? So you're going to have to tell me reject, fail to reject, and you're going to have to interpret that in the context of the problem. So if this is an association independence and you reject, what does that mean? Good, that's right. It means that there's evidence to show there is an association. Does it mean you prove an association? No, you just have evidence, and maybe the evidence is really, really strong, but you just have evidence to show that there's an association between the 2 categorical variables. Good? All right. So let's move on to the free response. So number 9. Now, let's think about a couple things. We always do 5 points per multiple choice. We always do 16 points per inference problem. So there are 40 points here. There are 3 inference problems. So that's 88 points total. So 9A and B is going to be worth 12 points. 9C is inference. Guess what? Good. Inference is right. All right, so let's look at A and B. The marginal values and the expected counts. So how do you find the marginal values? What's the marginal because they're in the margins, it's the totals. Good. All right, so you add. How do you get the expected counts? You do the chi-square test, right? So maybe we'll end up doing part C before we do part A, and that's okay. All right, and what type and why? So is it a bunch of populations, you're seeing if they're the same, you're doing homogeneity of populations? Is it one population, two categorical variables, you're doing an association independence? Tell me which type you're doing, tell me why you're doing it, okay? Inference, inference, inference. Here's how it's gonna go. 3 inference problems. One of each. Okay, now, how can we tell which is which? The goodness of fit test will have 1 row. Okay, remember, n-1 is the degrees of freedom because we can't do row minus 1 because there's only 1 row. So if there's 1 row, goodness of fit. All right, this is like the calculator problem that we did. I think it was an M&M's problem in the homework. Maybe you didn't buy M&M's because everything shut down. That's okay. Goodness of fit. Homogeny of populations. So this was the quit smoking problem, right? So the drug, the patch and drug, the placebo, the patch. So it was the different populations of what they took. How likely were they to quit smoking? Association independence, this was how likely you are to smoke if your parents smoke, I think is the one we did. So, you know, 1 population, 2 categorical variables, see if there's a relationship between the 2. You should be able to tell from the context clues of the problems what each one's going to be. All right, that's it. That's your whole test. Does anybody have any questions? No? You sure? All right. In that case, if you have any questions later, shoot me an email. I'll try to answer them before the test. All right? All right, thanks for listening.